Hello everyone, my name is Juan Medina. I'm an Ansible Specialist Adoption Architect at Red Hat. I've been here for at least 10 years now. And today I would like to talk to you about how to establish a healthy Ansible development environment. This is going to be a very comprehensive guide that will show you how to establish a very reliable, fast, modern environment using the best in class tools designed for very effective automation development. Now, one of the first things that we will notice is that developing Ansible automation starts with a very good foundation. All of our automation projects should be stored into Git repositories. This is not necessarily a suggestion. This is what is going to enable us from building strong, easy to maintain, small bits of automation, easy to audit, that will be transforming little by little into configuration as code, and that will allow collaboration among the things. Having Git repositories will help us separate our playbooks from roles, from collections, from modules, from all the different automation artifacts, and the benefits that Git it's going to provide us, besides the all well-known version control is and the collaboration, is that we will be able to focus on very specific portions of our automation process. The CI/CD integration using actions or similar tools from the Git repositories that are offered by the Git repositories, but most importantly, the fact that we will be able to reuse the code. Now, the other thing that we will discuss is about the essential supporting tools. Besides Git, we also need a strong IDE. Now, automation engineering goes beyond just creating Ansible playbooks. It is a whole discipline from developing, testing, and giving maintenance to our idempotent code that should be reusable and should be secure. It will transform all of our operational knowledge, all of our processes that are currently being managed in a manual way or using scripts or something like that, into a repeatable, predictable, and self-documented code. The disciplines among the code authoring, the version control, the testing, the dependency management, the documentation, security compliance, and all of those things that are necessary to have a healthy development environment. The establishing these will require the essential tools from Git, from an IDE, knowing what we can do with all the Ansible tools, the core of Ansible, and understanding what are the differences between having a local and a centralized development environment. Now, um, when we want to compare these different scenarios, we need to understand that at the end everything will converge into having a Linux environment. The reason I said that is when we bypass all of these sections and we install all of our tools and we understand what our tools are going to be, then we have multiple options. We can either do a local development or a centralized development, and we can see here in the graphic how the line is changing. So if we decide that we will do a local development, we can develop on Linux, we can develop on Mac, or we can develop on Windows. So let's say that we decide to develop on Linux. The foundation will be the same, the tools are the same, and the installation on Linux is going to give us three different ways in which we can perform our development. We can make use of Python virtual environments, we can just have a wide system-wide installation, or we can use containers to develop on top of containers. Now, on the other hand, if we decide to do it on Mac, the story is basically exactly the same, because at the end of the day, Mac is just a BSD system, which at the end is kind of like a Linux system, and the installation and tools and configurations for the most will be exactly the same. And you should know that at the end, I will give you, besides this recorded video, a document with all everything that I'm discussing. Now, on the other hand, the story changes just a bit if we are talking about Windows. When we develop on Windows, the requirements are still the same, the tools that we will be using are the same, but we will have to make use of a Linux on top of Windows, UWSL, a virtual machine, whatever you can use. Uh, but at the end of the day, everything goes back to the same Linux configuration. There is no way of having a out of the box working integrated Ansible environment that will work right on top of Windows. Now, this is if we decide to do a local development, which in most cases it's what we will do. Now, sometimes this is not enough, and we need to have a way of, because of governance, because of security restrictions within the organization, we need to have it all in a centralized server, or maybe because just convenience, right? In a centralized environment, we also have a couple of options. We can either develop using just an SSH server, which is just a Linux server, in which we will connect our Visual Studio Code, or we can set up a Visual Studio Code server. Whatever the case might be in these two scenarios, we still going back through all of the requirements in the exact same way, and then jumping into the Linux configuration, and we still have all of these different scenarios in which we can use our environment. Now, focusing on the needed tools, when we want to make the selection of an IDE, we basically have two major contenders here. We either use Visual Studio Code or we use Vim. Now, to be honest, I'm a Vim fan. I use it all the time, but I'm also a fan of Visual Studio Code because of the easy way to configure and use, and but most importantly because you can combine the two tools. So what I do is I set up my Visual Studio Code and I use Vim extensions, so my Visual Studio Code basically works like Vim. Now, Visual Studio Code is ideal for developers who prefer a graphical user interface and they want to have all the tools ready to use. Red Hat has created extensions for Ansible that work out of the box in Visual Studio Code. Now, on the other hand, Vim is ideal for those who are fan of working on the command line, or that for whatever reason, restriction, you can only make use of a remote SSH connection to a system, or where using an IDE becomes unpractical. Now, between the two, if you're not familiar with them, there is a learning curve. It's Visual Studio Code is easy to learn, quick, fast. And the other hand, Vim, it's you need to spend a little extra time in it, even though I don't think it's that complicated, but it does require a little bit more effort. In terms of support, there is better support for the extensions of Visual Studio Code. In terms of resources, Vim is very low in terms of the resources that we'll need, while Visual Studio Code might be a little bit heavier. Well, but that's because it offers a lot more capabilities, so that's expected. In both cases, we can make use of all the different scenarios that I will be presenting today. The other thing that we're gonna need is our Ansible packages. Now, there is multiple ways in which we can install these things, but let's start by installing Visual Studio Code. So I will go explaining one by one of the things that we can do with it. I have this virtual machine that I've set up at the moment. Shouldn't have anything in it. It's just a blank canvas, and I have also a remote connection to the same system, the exact same system, so I can easily just type my commands down. So the first thing that I'll do is just make sure that we have git sudo dnf install -y git, and we'll see that git is already installed. Next, I will import the keys for the repository from Microsoft, and right next to that I will copy the code for generating a Visual Studio Code repository that can be used with the DNF tool. Now that should be creating yum.repos Visual Studio Code, and this is going to allow us to maintain always up to date our Visual Studio Code in our system. To install Visual Studio Code, I will just run a check update and then just a DNF install -y code. It goes and installs Visual Studio Code, and we should be able to see in our system that Visual Studio Code is now available. If I open it, I can of course just go ahead and start bringing all of my extensions by going into the extensions and searching for the things that I need. So if I need Ansible, I can just search for Ansible and I can start doing those installations. Now, I don't want to go through this process manually, so I'm going to show you how to install all of your extensions in the system in a more automated way. So let me start by going to my terminal session, and I will clone a repository of my own in which I have created some of these tools that we will be using. Let me start by creating a repos folder. I already have it there. Let me remove that old version, not sure, and I'm cloning. There you go. So if you look at this, this is nothing else but a repository with a very basic structure of a playbook and an inventory. There's nothing special about it. But then if we do a git branch -all, it shows me all the different branches that in the remote that they're available at the remote, right? So in the configs branch, I have the configuration files that we need. So let me check out to it. I'm going to check out to the configs, and now you will see that the content is slightly different. I have a lot more things here. Within this content, you will find that there is the vsc_ext.sh file. This is a simple script that runs through a list of files, extensions that can be found within the extensions.txt file. So if I look at the extensions file, you will see that it's just looking by name all the different extensions that I will recommend you to use. Some of them are very familiar, like all the MS, all the extensions that start with MS. Those are the Microsoft extensions for Python and Visual Studio Code. Then you have the official Red Hat extensions. They start with the Red Hat. And then I included other extensions that will be that make your development process very easy. Some of them to manage your projects, some others for adding linting capabilities, some others related to your Git repositories, etc., etc. Of course, you don't need them all. They are all absolutely optional. But the ones that you definitely need are the Red Hat related ones and the Microsoft ones at the same time. So in order for me to execute this, I will just run bash bsc extension, and this is gonna take a few minutes. So while this is running, I'm gonna pause the video and be back. Okay, the installation process of all the extensions has completed, and now let me show you. If I go to my Visual Studio Code, I can now open my Visual Studio Code, and you will see that all the extensions are now included into my system. Let me make it slightly bigger so you can see them all at once. You can see they're all listed on the left side. Of course, I don't need to see them all right there, so I'm gonna remove some of them which are unnecessary right now. And there you have it. This is how the Visual Studio will look like, and some of the things that we will have to configure. Now there's a couple of items that I love to change, to modify in my configuration, and that is to set a couple of keyboard shortcuts. So I will do Control Shift P. That will help me search within my configuration, and I will look for keyboard shortcuts. So if you open Preferences, open Keyboard Shortcuts, then I can search for Toggle Maximize Panel. You see it right there. So I'm going to double click on it, and I like to open my panel, that is my terminal session, by doing a Control Alt P. That will toggle my panel. Now I will hit enter. Then I will search for the toggle send mode, and I will do this double click, Control Alt Z as in zebra, and hit enter. So those are the only configurations that I usually change within my Visual Studio Code. So now every time I do Control Alt P, it just opens my terminal, and if I do Control Alt P again, it toggles the terminal down, which I usually keep it like very short, maybe just one line at the bottom. And then if I do Control Alt Z, it goes into send mode, so I can focus on just the document that I'm looking at the moment. And if I do Control Alt C again, it shows me the entire application. So at this point, we have covered the foundation, which is installing Git repositories and setting up the IDE. Now I'm going to move into setting up Ansible and all the core requirements. But in order to do that, I'm going to start taking in one of the main ways in which we recommend you do your development, and that is by making use of Python virtual environments. Now, to do that, we're going to have to install some tools. So let me move on to the terminal session. I want to clear my screen, and let's install the basic requirements. This is going to make sure that we have Python, that we have pip, that we have the development libraries for Python, GCC, and some others. Now, every time you do Python virtual environments, it is recommended that you start by making a project. So I'm going to remove the project that I did before, and I'm going to create a new one by saying make directory and cd into the directory. So at this point, I have a new project, It could be coming from a Git repository, of course. And now I'm going to use Python with the module virtual environments to create a new virtual environment called project 1. Now this new environment has been created. All I need to do now is activate the project. So now that I'm in the project, I can start installing the requirements. So the first requirement will be to upgrade pip. I will make sure that I have the latest and greatest version. And the next thing to do is to install all the Python tools. Now, if you notice, I'm installing Ansible, the Ansible Navigator, linked molecule with multiple drivers. So it's molecule with Docker, with Podman, and with the linter, Ansible Builder, Ansible Runner, and the Ansible Creator, which is the kind of like the latest kit on the block. So let's run that, and it will use, because I already had that downloaded them before, it's using them from the cache, and then it will run the entire installation. So while this is going, I'm gonna pause the video for a second. All right, the installation just complete, and at this point we should have Ansible and all the related tools ready to be used in an isolated environment. So if I needed to have multiple projects, I can just build another project, just create a new virtual environment, and set my different tools in it all over again. Now at this point, I can also make use of pip -- list. It's just list to get the list of all the different applications that I have installed with version, which is going to help me build a requirements txt file. So if at this point I'm done working with this and I want to create a requirements file, I can just grab for Ansible and molecule and send this to our requirements.txt. And if I look into my requirements file, it's gonna look something like this. So all I need to say is make it equal to this specific version. And if I want, I can also say greater or equal to this specific version. I have many different combinations that I can use. Now, in the case of molecule, because I need to install it with multiple drivers, I can list those drivers right here and say Podman, Docker, and the lint with the version this way. And again, there's many ways, many combinations that we can use to set up our list of requirements. Now, I already have one file ready to be used. So when we are done working with this project, working with this virtual environment, we can always just run the deactivate, and that will take you back to your local system. So what if I wanted to do the exact same thing from Visual Studio Code? I can, of course, go to Visual Studio Code, and in the Python section, I have my virtual environments. I can add a new virtual environment. Let's open a folder, and I can just bring the project in which I'm working that already has a virtual environment, or I can create a new project. So let's bring that one up. Click select, and if you notice, my files are in place. I can trust the authors, and of course I can always just open my terminal, and you will see that Ansible and all the related tools are in my project. I can always come here and close it. You should be able to close it here. So close the folder. But what if we don't have the need of working in a specific isolated projects? Well, we can always make use of wider installation, just one installation of our system, and that's commonly used if you don't have any specific requirements. So if we're gonna do that, same story, same pip commands, same everything, it will just go ahead and install it. The benefits or the pros of this is that it's simpler. It's just one installation and you're done. Ansible is there with all the tools in a global manner, system-wide. The cons is that you have less isolation between your different projects. If at some point you have dependencies on Python libraries, shell scripts, or whatever it is that you're using, there won't be any isolation between these different projects. So we have to consider the third of our options, which is making use of containers, which goes hand by hand with the more modern way of developing things, and it kind of goes hand by hand with the newer Ansible automation practices, which with execution environments, right? So for this, we only have one prerequisite, which is having a container engine. You can do this with Docker, you can do it with Podman. We recommend the use of Podman because it's our product, right? But then once you have Podman in place, then you will have to generate a new container image. Within the configurations in the repository that I'm sharing with you, there is already a container file. So let me open that container file and let me quickly go through it, and you will see that what it's doing is taking an image, which in this case, for simplification, I'm making use of a Fedora image, but you can always make use of a Red Hat, of course. Then I'm running through and upgrade the system, install the same Python applications and libraries and requirements and prerequisites. We clean the system a little bit. We generate an Ansible user. It can be whatever name you want, but this is kind of like a common standard. And we make sure that Ansible user has sudo access within the container. Then we switch to the Ansible user. We create a project folder in which your working project will be mounted. And then we make sure that all the pip is upgraded and that the Ansible tools are installed in place. And if needed, you can also install some of the collections from Galaxy as well. So at this point, all we need to do is build this image. So I'm gonna run this process. I got that error because I missed one backslash in this line. Let me check I'm not missing any other. No, I think that looks good. All right, let's try again. And while this process is running, because it's gonna take a while, I'm gonna pause the video and come back. Okay, once the installation, the build process completes, we can look at our images and we can see that now we have one new image, the Ansible development environment version 1, which we can use to run our containers. So let's run a container and see what's inside. We can do a podman run with a TTY in an interactive mode. Let's name this container Ansible. Let's give it a host name as development environment. In order for us to run this, we need to be sure that the security option label is disabled. This is going to ensure that SC Linux is not messing with us while we are running the container. And we also need to make sure that the username space equals keep ID. That is to ensure that even if our user outside of the container is not the same as the user inside of the container, there will be no conflicts of permissions for us to be able to access our projects. And the next thing that we have to do is mount our project, the thing that we want to work with. So I will say mount. The source in this case is going to be from my home directory into the repos directory, the hello app project. And I will mount that, or I can just leave it as repos if I want to access all of my repositories. It's either or. And I can also, well, let's just mount that repo, and let's put the target, which is going to be a home Ansible project. Remember, that is the project, that is the folder that we assigned as our destination. And the type of mount will be a bind, and that's all we need. Let's make another line, and we're going to be using the Ansible development environment. And did I miss attachment, source, target, type, Ansible dev, and version 1. Let's hit enter. So after a few minutes, you will be as the Ansible user inside of the development environment, which means you are inside of the container. And if you notice, by default you are in the project. So when I list, I can see everything that I mounted from my local system into the container, which means that I'm in a completely isolated space working inside of Linux. Even if I was working on Windows, as long as I have a container, I will be working on Linux, and I will have access to all the required Ansible tools, just the same as in any other environment. The great thing about this is that now this is completely isolated, secure, very easy to reproduce, because if I want all of my developers in the organization to make use of the exact same environment, all I need to do is publish the image of this container, and everybody will be using the exact same resources. It's very easy to maintain and support, because if there is a newer version, new libraries, new collections, or whatever I need, I can just set it up into the image, and everybody will again be using the same. And then I can, instead of just mounting one project as I did here, I could be mounting just my repos directory and have access to all of my projects at once, which breaks a little bit the isolation between the projects, but at the same time it brings the utilization and the isolation of the container. The only con of doing this is that you need to have some basic understanding of how containers work. Now, if I make a change to my environment, let me create a new system. I'm just going to do a couple of new files. I'm going to call them A, B, and C. And if I exit the container, just like I will exit any Linux system, Control D, that kicks me out. And I can see that A, B, and C are in my repository. So using Git repositories, it's very easy through the containers as well, because at the same time, once I'm back into my local host system, I can just commit and push and do whatever I need. I can also do it from the container, but just in case you want to separate those two parts of the process. Now, what if I want to make use of Visual Studio Code, wherever I have it installed, with containers? For that, I will have to make use of an extension called dev containers or development containers from Visual Studio Code. It is, well, not that straightforward, but once you understand the process, it's not that complicated. Now, if you notice within my configurations, I have in the hidden folders this directory. All you need to do is create the directory .dev containers, and if I go into that directory, you will notice that inside of that I have another file called dev container.json. So I'm going to open that file to show you what's in it. And if you notice, it is a JSON file and it holds how do you want your container to look like. And this is a very extensive version that I kind of like modified so it works the same as the container that I just showed you. And if you go to the top, you will notice that you give it a name. This is going to be the name of your environment. You pick an image. That's going to be your baseline image. Now, if you notice, I'm running from Fedora. Then you say, how do you want your working space to be mounted? So by doing this, you're saying my local folder, wherever this file is located, will be mounted into the target system at this directory. And if you notice, that is the exact same target that we used in our previous container execution. To set this is a bind mount, and I want to mount it with cache. Then we specified what's going to be our working folder. This is the same as doing a work directory in a container file. And then we pass some running arguments. So we will just go a --init. If in case of shutdown, don't do anything, don't restart it, don't do anything special. And then we will specify some features. Like one of the features is that we want to have a username called Ansible. This is the same as creating the user, and the user ID will be 1000 and the group ID will be 1000. So we are basically just creating a user. Then we have a whole list of post create commands. This, if you notice, are the exact same commands we had in our container file. If installing, upgrading the system, it's installing Python, it's installing all the prerequisites, and then it's making sure that Ansible is installed in place by making use of pip. So if you notice here, by making use of pip, it's running the installation of pip upgrade and pip install and all of those things. And then we ensure that when we are connected, we are working as the user Ansible. And we also have post start commands. So this will make sure that there is no SSL verification, that in our Git configuration, that our user, our email and stuff like that from Git are in place. And then we can include the specific customizations for our Visual Studio Code. So if you remember our extensions txt, it was a whole very long list of extensions that were installed into our Visual Studio Code. Now, because in this case we are working remotely through a container, these extensions will be installed in the container. So this is even better than just having the container itself, because now the extensions are part of the container as well. They will be part of the image as well. Once you have it in place, we are just saying extra settings again for Visual Studio. So we're gonna specified how to identify our YAML files, where is going to be our Python interpreter, our linter. So these are configurations that we don't need to do manually. They are done, they're being applied automatically. So that's all we need to have our dev container in place. Just create the folder, create the file, configure it in a way you want it, and now how do we make it work? All we need to do is go to Visual Studio Code, Let me open this and just regularly open Visual Studio Code and open the project you want to work with. As long as that folder and that file exist, it will automatically detect that the file is there, and it will ask you, let me go to my repos and open this folder, select. It will automatically detect that you have it, and if you notice, it says the folder contains a deb container configuration file. You want to reopen this into a container, so let's click on reopening container. Now we can ignore that. We need to do a little configuration to have this working. So I'm gonna click on cancel, because this by default deb container suspects you to have Docker. So because we don't have Docker, I'm gonna click cancel, and I will search for that configuration. I'm going to accept that, close this, and let's open Control Shift P, deb container. So all we need to do is Control Shift P, deb, search for the deb containers settings, and once it opens, you just need to look for the path for what it says Docker path, and change this for Podman. There you go. We can close it. We should be able to close the folder, and let's open the folder one more time. We receive the warning that says reopening container. Now it's opening. This is going to take a few seconds, so I'm going to pause the video. Okay, I got an error because if you notice, I'm trying to make use of the Fedora from Microsoft. That's not going to work, so let me change that to make use of the image that we created. So we're gonna be using the same image we used before, and that is gonna be our baseline image. So this right here, I will copy. Now, of course, that image we know that comes already pre-configured with a lot of the things that we are asking to be done here, which should accelerate the process. And of course, we can always keep control of the things that are happening. So let's give it a try one more time through the interface and open that project. Notice that because it was open previously and it automatically detects that we want to open it through the container, it will just go straight to it. Now while this is running, I'm going to pause the video and be right back. So if you notice, the first time you run this process, it will take a while the first time because it's doing the same thing we did before. It rebuilds an image that is usable for Visual Studio Code. So it goes through the whole building process. Now it's connecting to it, and now that we are connected, we can see from the terminal that we are connected to the exact same repository from a container. We have access to all of our files. We are running as the user Ansible, but we are not in just a regular terminal. We are literally running from Visual Studio Code. All the Ansible tools are available, and then at the same time I can just straight work within my container, which is already pre-configured and ready to be using, let's see, there you go, the linter and all the other requirements. Now if you notice it's going very slow, that's because of my specific environment. This virtual machine that I'm running, it's in another computer, so it's going a little extra slow. But then at the same time everything is there and is ready. So up to this point we have covered all the different scenarios that we can use to develop through Linux using virtual environments, a system-wide installation, or using containers. In all cases we saw kind of like the standalone version versus Visual Studio Code version. Then if you want to use Macintosh, the process is basically the same, and if you want to use Linux, the process is the same, but you need to do it through a WSL or a Linux virtual machine. So there is the option of using Podman or using Docker, and all of the specific instructions will be provided in a document. The thing that we haven't talked about yet is, what if we don't want to develop locally? What if we want to use a centralized development module? In this case, as mentioned, we have two basic options. You either develop using Visual Studio Code over SSH or with a centralized development server, or you use a Visual Studio Code server, which is going to allow you to, through the browser, under any platform, call it a computer, a tablet, or a cell phone, or whatever, you can connect to the system and you will have a fully configured Visual Studio Code through your browser. So let's explore these two options. For the Visual Studio Code over SSH, we need a server. So I have another system here. This is a Red Hat 10 system. Of course, you will need SSH connectivity to the server and valid credentials, right? A user that you can SSH through into the server. The benefits of doing this, it will give you excellent performance. You will have all of your tools globally installed in the server. You can still make use of containers. You can still make use of virtual environments. The pitfalls, on the other hand, is that it might require a lot of resources like CPU and memory, because each and every user making use of the development environment will have to be running their own individual container. That's for one. Or they might have to be running their own installation of Visual Studio. Whatever the case might be, it's a little resource expensive, but then at the same time not so much that is not controllable. What I have seen other teams doing is having multiple small centralized development environments per areas. So networking team may have their own development system, and the Linux administrators may have another one, and so on, so they don't mess with the performance of each other. On the maintenance side, it's very easy to maintain, having molecule and all the tools in one place. The pitfall is that again every user will have to run their own pip installation and pip tools in place for their unique use. So in this case, what I'll do is that I'm going to use this Fedora system as my client, and I will use this Red Hat system as my server. So the first thing that I need to do is set up SSH keys. So I will do SSH key generate. Let's do a type. Let's pass our email. I'm not gonna put a password to it. So in my case, I just set it up without password just for convenience, but of course you can set it up with password. Now let's have this new SSH key to be recognizable. That just means that my agent is not running, so let's take a look. Now the agent seems to be there. Let's try to add it again, and now it's my key is added to the system. So the next thing, it's now that we have the environment, let's add this remote system to our etc host. So let me get the IP address. Let's just call it remote server. Again, this is just for convenience, and I'm gonna copy my key to the same user on their remote server. Oh, I missed the key. That's why it was not auto-completing for me. Okay, of course I know that the user has already been created in the remote server, so the user needs to exist over there. Okay, now that we know that we have remote connectivity to the system, we can say remote server. Let's just start getting the host name, and we can get the host name that proves that we have access to it. We can go and use Visual Studio Code. Among some of the extensions that we install into Visual Studio Code, there is the remote extensions. I'm going to close this folder, close the remote connection, and make sure that the folder is closed. Okay, so I'm not connected to anything right now, and what I'll do is go to this Remote Explorer extension. I'll click on it, and you will see that among all of the things, you see you have remote repositories, you have your dev containers right there, the development volumes, but you also have your tunnels for SSH. Now if I hover over the SSH, I can click on the open configuration for SSH, I will select the default, the one that belongs to me. It's part of my home directory, and it will open the kind of like the default configuration. Right now, this default configuration, I'm going to modify it so it uses my remote server. The host name is remote server as well, because that's the way I set it up in my host table. The user that I use to connect is jmedinar, and the identity file it's the one hosted at my home directory under the .ssh called i_d25519, and that's all I need. So I'm gonna close and save, and that should be everything I need. And this is something that you can do on Mac, on Windows, on any system. The remote system is the one that has Linux. Windows only has Visual Studio Code and nothing else. And once I come over here, I can refresh my list, and you should see that my remote server appears within my list of SSH remote connections. So I'm going to click on connecting the current window. It will set up everything that is needed. Let me try again. Okay, let's modify that configuration, and instead of making use of maybe I have the wrong name. Give me just a second. I'm gonna check. BTC host. It's remote_server. I'm gonna check that configuration. Oh, I put a dash. It's remote_server. There you go. So let's try again. I'm gonna connect. Notice that it's making the SSH connection, is downloading Visual Studio Code. It's not a full, complete Visual Studio Code. It's just the bits and pieces necessary to connect my current UI to the remote system. So it's better performant than having the entire application, because the application is installed locally. So now that I'm here, you will notice that I can see this option to say open folder. Now when I say open folder, remember that I'm not connected to my local system, I'm connected to the remote system. So I'm going to hit open folder, and notice that automatically brings the home directory of the remote system. I'm just going to hit OK, and I'm now connecting to that remote system. I'm going to trust, say yes, and now I'm connected to the remote system. So at this point, I can treat that system as my system, and I can start creating new projects using Git, cloning, and working with my project. So everything is connected there. So at this point, we have a fully functional remote connection. Now let's explore our last option, which is setting up a Visual Studio Code server, which is slightly different. For that, I'm gonna close Visual Studio. I'm gonna close this terminal as well, and I will go back to my server, my remote system running Red Hat. So I'm gonna clear my screen. Nothing has been done in this system. Now Visual Studio Code server has some advantages and disadvantages, just like everything. The advantages is that it takes all the heavy load, the CPU, the RAM, and the space requirements to the remote system, not to your workstation. It allows you to work through the browser, which if you have very little resources in your local system will not matter. It's not going to have that much of an impact. It allows you to work on a tablet or different devices. The pitfalls is that every single instance, every single user that will be using this requires its own configuration. So that's kind of like the, the only thing that you have to be aware of. Every single user will have to go through the configuration of its settings. But at the same time, it makes it individually customizable for every single user. Now, the installation, there is a script provided by Microsoft that you can use. So you just need to run a command just like I'm doing. Notice that I'm the root user, so I need to be root in order to run installations and stuff like that. And now it's downloading the RPM package, and it will run the installation, and it will set up the Visual Studio server for you. It takes a few seconds. Okay, even though you get a warning there, the Visual Studio Code server has been installed, so all we need to do now is enable it. Now this enablement happens per user. If I take a look at my users right now, I have a user for myself called J Medinar. So if I want to set an environment for that specific user, I will do a sudo systemctl enable dash dash now. That will enable and activate at the same time a code server for J Medinar. And you will have to do this for every single user. Now hit enter, and now the server has been enabled. Now, in this case, the Visual Studio Code server by default comes enabled to work on the local host. So we need to modify the configuration per user so the user can make use of the system. Now, the most common thing is just to put it on the 0.0.0.0, so it's usable on any network, but at the same time you can just be very specific and say, if the system has multiple networks, let's use X and Y network or whatever you want, right? So in this case, what I'll do is just go to the configuration of the user. Under the config code server, there is a file called config.yaml. When I open that file, I don't have Vim. You will see that by default the bind address is to the local host. So let's change this so it works on all networks. Also notice that there is a specific port. You cannot repeat ports. Every user will have to have its own port. So set up a number. Let's say I want to do 10,000, and from port 10,000 all the users, next one will be 10,001 and 10,002 and so on. Also notice that the password is randomly generated and it will be unique per user. You can change it, you can set it up, there's ways to set it up, but it will be unique per user. Now at this point I'm going to save it, and I need to restart the process, the service for this specific user. So I will do a sudo systemctl restart code server for J Medinar. Now I can go to my workstation, Oh, I forgot to do one more thing. I need to be sure that the firewall is open for that specific port. So I would do a sudo, well, I don't need sudo, I'm root. I just noticed firewall cmd to the zone public. Let's add the port 10,000 TCP. Let's do it permanent, and then let's do a firewall cmd -- reload. Zone equals public. Sorry. There you go. All right, so now we have it open, and we can go to our remote system. We can open our browser, and because we have configured in our host table the remote server as remote-server, we can just navigate to the port 10,000. Let me try HTTPS. HTTP. Is it 10,000 remote server? Let me make sure again. It's underscore server. I keep forgetting that. It's underscore server. There you go. Now it's asking us for our password. So let's get the password from the remote system. I'm going to do it by running a command to extract it. So I will just do SSH to the remote server, and let's grab for the password into the .config code server config.yaml. We get the password and we submit. So if you notice, this opens the configuration. We can of course at this point start adding our extensions, connect to our remote system, basically do all the things that we have seen, work with containers, work with virtual environments, set up Python, set up all the tools, and we have an entire system running as a code server. Now that is all I have to show in this video. I will make a second video to show how to make use of the tools. Thank you.